Good morning. It's a pleasure for us to show you our investigation that is e-learning and m-learning technological intervention in favor of mathematics. We are a team from Ecuador formed by Omar Condor Herrera and Carlos Ramos Galarza. We are for by universities, two universities from Ecuador. University in America and Católica University from Ecuador.
Abstract. This paper is based on pre-experimental research that assess the impact of e-learning and e-learning technological intervention to promote mathematical skill learning. The sample consists of 16 students between 11 and 12 years old. They receive an educational technology program for 6 sessions. Pre and post-test measurements were performed to assess direct proportionality knowledge and ability to solve problems with two artifacts respectively. The result showed a statistically significant difference between the pre and post-test, and consequently, it is highlight the improvement that the learning process based on e-learning and e-learning has in the learning process of mathematics. As evidenced after the intervention ended, the data is discussed around the need to incorporate this type of technological tools in the learning of calculation skills and previous research. Keywords are e-learning, m-learning, BLA, and ICT.
Introduction. The technological revolution has changed humanity in all its spheres. Cultural processes have gradually taken turns not only in the forms of production, representation, and diffusion of knowledge, but also in how to access it. Each society has had to update its teaching models. Also, this transition has not developed at the same rate as technological progress. Situations currently experienced in the world have abruptly forced several countries to rethink the approach of their educational system to move to a pedagogical model of teaching based on information and communication technologies developed in virtual learning environments and giving way to e-learning and m-learning education with all resources, possibilities, and tools that technology offers today. The teaching and learning of mathematics have always represented a challenge for the educational community, resulting in extensive research in innovative ways of teaching mathematics with the support of technology. Borba et al. Made research focused on digital technology and mathematics education, where the use of mobile technology and virtual environments are considered effective devices to generate significant learning. Also, positive results such as motivation improvement, commitment, and access to technological learning environments have been found when technology is used in virtual learning. In this sense, this research shows a longitudinal pre-experimental investigation that developed a technological intervention program based on e-learning and m-learning to improve the learning process of mathematics in primary school students.
Benefits of e-learning and e-learning in education. E-learning benefits. E-learning or electronic learning arise as a direct result of the integration of technology into the educational field, including the implementation of a wide range of multimedia tools such as the internet, interactive television and web page, dynamic platforms, and all forms of electronic support, which favors the learning of mathematics, making it flexible and much friendly for students. As mentioned by Corbett and Spinello, the difference that e-learning offers in relation to conventional education is that the process of construction and assimilation of knowledge take place in a virtual environment. where the advantage offered by Web 2.0 allows the creation of online learning communities. Within connectivities, learning occurs when peers are connected and share opinions, points of view, and ideas through a collaborative process. Due to the popularity of this type of teaching, it is the implementation has improved more and better resources have appeared to potentially PLAs reaching not only conventional desktop computers, but also mobile devices such as smartphones, tablets, among others, leading to the appearance of e-learning.
What are the e-learning benefits? As mentioned, the application of the Web 2.0, the electronic learning allows visualizing new forms of teaching and learning. Part of these possibilities is e-learning, which through the use of mobile devices allows access to information on different topics and areas of mathematical knowledge, science, language, among others. Additionally, software applications allowed the teacher to implement different types of activities in innovative ways. Thus, M-learning facilitates the pedagogical process as students can access a wide range of contents and activities without time or geographic location limitation. The effectiveness of this type of teaching generates great benefits in student learning. For example, in research done by Ramidiani, the results showed a positive correlation between the use of smartphones and the quality of learning. Therefore, understanding new academic concepts and improving study habits will be eased by understanding the function or virtual learning benefits.
The hypotheses of the investigation are hypothesis number one, students under the e-learning and e-learning technological intervention will show improvements in the learning of concepts on direct proportionality when comparing their performance before and after the intervention. Hypothesis number two, students under the learning and learning technological intervention will show improvements in their mathematical skills to solve problems about direct proportionality before and after the intervention.
Methodology. What were the participants in this research? The group consists of 16 participants between 11 and 12 years of age, where a woman and men participate in 37% and 62%. In all cases, the ethical standards for research with humans were complied with. The voluntary participation was respected and the physical and mental integrity of all participants was safeguarded in each phase of the study.
Artifacts. Two artifacts were valid to perform pre- and post-test evaluations. The first artifact assessed the different proportionality knowledge and the second one the direct proportionality problem solving. Intervention protocol. An e-learning and M-learning intervention program was developed in favor of learning mathematics on direct proportionality focus on improving the master level of knowledge and the ability to solve mathematical problems on the topic raised. The intervention was applied for 6 work sessions, where the e-learning and e-learning strategies were applied: A, virtual class; B, video quiz; C, serious game; D, quizzes, questionnaires; and E, flashcard.
Procedure. It is important to highlight that this research was approved by Ethical Committee of Investigation with Human Beings of the University in America from Ecuador. Participants' representatives were asked to sign the informed consent of voluntary participation. The consent was signed and granted by all parties without any exception. Throughout this research, ethical standards of investigation with human beings were followed. protecting participants' physical and psychological integrity at all times. Once the respective authorizations were obtained, the procedure was done. Finally, the databases were completed and the respective analyses were performed.
Results. First hypothesis in favor of knowledge difference. In the table 1 shows the descriptive values found in the artifact that quantified the knowledge of direct proportionality in the pre and post test. Knowledge pre-test, the median 1.75, and knowledge post-test, the median is 4.50.
Subsequently, to analyze the first hypothesis, the student's t-test was applied, in which a statistical significant difference and a large effect size were found between the pre and post-test measurements, which provided empirical evidence in favor of the first hypothesis. You can see these results in the table number 2, where is the statistical data, mean, standard deviation, the value of t-test, and the p-value significance.
The second hypothesis in favor of problem solving. In the table 3, it shows the results found in the assessment performed at the pre and post-test level in the artifact that evaluates problem solving. You can see in the table 3 the results, the investigation. The problem solving pre-test, the median is 1.88, and the median problem solving post-test is 4.25.
In the statistical analysis done to analyze compliance with the second research hypothesis, it was found that there are statistically significant difference in a large effect size between the pre and post-test comparisons, which provides empirical evidence in favor of our second research hypothesis. Table 4 shows the comparison made.
Discussions. This research shows the result of pre-experimental investigation that I made to analyze the impact of an e-learning and a learning intervention program in favor of learning mathematical concepts about direct proportionality and the problem-solving ability of these mathematical skills. To obtain the data, two artifacts were applied in the pre-test. The first measurement, the understanding of mathematical concepts, and the second, the ability to solve problems. Subsequently, the intervention was applied in work sessions with students using virtual classes, serious game, video quiz, among other e-learning and learning activities. Once the intervention was complete, the post-test was performed where the same skills as the pre-test were measured. The third hypothesis proposed that the students under the e-learning and learning technological intervention will show improvements in learning concepts on direct proportionality when comparing their performance before and after the intervention. When comparing the results obtained between the pre and post test, a statistically significant difference was found. The initial measurement of the group was 1.75 on average, and in the final measurement, it increased to 4.50. This provides evidence that the use of e-learning and e-learning improves mathematical knowledge concepts such as direct proportionality. The second hypothesis states that the students under the e-learning and e-learning technological intervention will show improvements in their mathematical skills to solve problems about direct proportionality before and after the intervention. The comparison between the pre and post-test results showed a statistically significant increase. The initial measurements of the group was 1.88 on average, and in the post-test, the result rose to 4.25, which allows us to affirm that the use of e-learning and learning improves the ability to solve mathematical problems in primary school students. The results of this research are similar to studies such as those of Malik, who affirmed that the use of a technological application improves the understanding of concepts and enriches student learning. Furthermore, they point out that e-learning based on a smart mobile device is compatible with the problem-based learning pedagogy. The results are obtained beneficial for learning as supported by the results of this research. The limitation of this study lie in the lack of a control group to contrast the results obtained by the students under the intervention, as this could have enriched the data presented. However, this factor becomes a motivation for the future studies with the technological application in favor of learning mathematics, including control groups and also increasing the sample size.
In this slide, you can see our references, and in this investigation, one of all authors, the corresponding author states that there is no conflict of interest. Thank you so much for attending our presentation.